So one thing I wanted to show is finally end with is exception handling. So exception handling has keywords try and except. Those are the minimum ones you need. Try is kind of like an if statement. If this, then do it. Otherwise, if it fails, do the except. So this is just an instance. You don't have to do this. When I'm importing IP address, part of the Python core, I don't have to load it as a package. But here I'm trying to get an IP address. This is just using the functions in it, irrelevant to us. But I'm doing input. I'm prompting the user for an IP address, and this is going to be my default value. So this function right here, if you get a null value, such as I hit the return key, it's going to throw an exception, and I'm going to catch it, and I'm going to do this part. I'm going to set IP address to 127.0.0.1. So exceptions are not just for errors or issues. I could be doing it, such as I am here, to get a default value. And you can see it's waiting for my input down below here. So I'm just going to hit enter. It hits the exception, setting the default, and the address is that, and I just print a line, and then I print the address is set to 127.0.0.1, and I can prove if I set it to something other than the default value, which it's waiting for right here, I can put, 192.168.1.56, and it will set that. So it did not run the except part, right? So try and accept. You try on something. If it fails, you run the except. It could be if there's an error. It could be just to set default values. So that worked. This from the text also. So this is numerator and denominator. We're going to try division. In the try, we're going to divide the two numbers passed to the try syntax function here. And we're going to get the result. But if you divide by 0, it's going to throw a 0 division error as XDE. And then we're going to print that XDE result that Python gives us if there's an error. Notice it does give a specific function or a specific exception. So before, I just put except, which means any exception. So if I don't know the name of the exception, I can just put except and I'll grab any issue. If you know the specific name of the function, you can do that. Sometimes results can throw more than 1 or 2 of these, or 3 or 4. You can nest and just keep putting except in the exception name, except in the exception name, like keyboard interrupt, things like that. So it will try to do the divide. If it's a divide by 0, it's going to throw this. I'll print it. Otherwise, if it doesn't fail, it's going to print the result here. So you can have an else. Think of this as an if, this is an else. And then the last part of exception handling is the finally keyword. Well, finally will always execute. So whether the try succeeds, the except succeeds, or the else succeeds, finally will always run. So if you're trying to open a file or do something on a file and it fails and it's just going to mess the program up, you can always use like a finally to close all your file handles or your database connections cleanly, and then exit the program if you had to. So if you always need something to run, no matter what happens in the try except, you add a finally clause. But you'll notice the else and finally are not always required, because I only did the try and a plain except to catch everything. And then I'll pass 2 values, 12 and 4. It's going to come here and it's going to divide 12 by 4. It's going to put it in result. Since it doesn't fail, it's simply going to print the result, and it does return the result. So I can capture the result as well. Like I can do value equals try underscore syntax 12 comma 6 and print, I could do the value is value. So we can do that as well. It does return if it succeeds. If it fails, it doesn't return anything. But this one will succeed. So we can rerun that. Let me get rid of the plots. Let me just hit enter for IP address. So you can see that it does give me the value back, and I do print it right here. That's after the finally runs. Finally always runs. Then I get my value, and then I can print it. So there is a return. I'm just not capturing it here because I don't care. And then another one is to do 11 divided by 0. That's going to throw this exception, and then it's going to print exiting. And that's what happens here. So it's in it. It tries it. The error message is division by 0, and then the finally does exit. So a lot there. So a lot to try. Practice on some of that, especially the functions and exception handling and plotting. And if you have questions on any of these scikit-learn models, you will get into these in later classes and maybe run basics later in this class. But just to understand the importance of train, test, split. Scikit-learn is basically where your programming language and your data meets the models or the algorithms to do data science. So that's the value of scikit-learn. So if there's questions, let your instructor know. Issues, let them know. Otherwise, have a good week.